Yeah, this is package specialization on the 22nd of May. So yeah, let me share the agenda. I don't have anything. There is anything on the agenda right now.
Yeah, Wim, one thing I wanted to bring out is today is ideally the code freeze. So probably we should check where we are on that one from the group perspective. I think we are in a very good shape in this particular group. I still wanted to make sure that we go over that one.
Yeah, no, for sure. Yeah, definitely. If we can go to the board, right? GitHub,
yeah.
Nephew. So the only thing that I don't have the status upon is projects, the board, and then we have package specialization, and then yeah. So this is the IPAM VLAN backend. This package is submitted, but the code is not merged, right? But the package I submitted in the group of the package management. So from John, right?
Yeah.
And then the pipeline test, Isti, I thought this is done, right? Is that correct?
Yes. So I mean, right now the tests themselves are failing. So, but the test system is done. The tests themselves are failing. I can quickly fix it. So I can change the test case so it will be green. And I think we should do that. It relates to what we just discussed, I don't know, 5 minutes ago. So if we do that, then of course, then all of these test cases magically became green, but not to wait. If we don't want to wait for them, I can just simply add one line to a test case. Everything will, I can actually do it right now. And then we can merge this. And then after we do the change that we are discussing right now, then we can talk about if we want to change the test case or not. So should we do this?
Yeah, we should do that. Yeah. So just to be clear between everyone, what is failing right now is the following. So Isti did the pipeline testing, right? And of course, with the pipeline testing, you can change orders of functions and what have you, right? So of course, if you don't follow the order that we agreed, there are some failing cases, okay? So now I can solve these things, but we are adding complexity and I'm against doing that. And so we know the reason of the failures is actually, so there is 2 enhancements that we should do, which allows, which basically circumvent this problem rather than building a patch on a patch, basically. And so that basically what we have been discussing so far to change. And the reason is because so there is 2 causes of it. One is because so we need to do this more advanced diff, and actually that will solve the problem that Isti has found. Because right now what you see is that what happens. So the normal pipeline that we follow is normally we run interface, we run DNN, we run NAD. We run then IP and VLAN, right? And then we run interface again, NAD again, and then we run NF deploy, right? Now, if you change the order, for example, if you run NAD first, without being depending on interface, it creates an error or it exits because it was expecting interface. And we don't supply that because there is nothing, interface did not run yet, right? So it basically fails because of that. Now, if we do the change of the advanced diff, then NAD will not even ask for interface because it will either get the information or not, and we don't run into this error. So that's, and also it simplifies the SDK quite a bit if you do that. So I'm proposing to go for that change rather than trying to build a patch on a patch on a patch. And then we create more and more complexity, which eventually will bite us, I think. So that's a little bit the status. Is that clear to everyone or not?
Sorry, Wim. I don't think I caught that. Everything what you said. Maybe just me. So is it a change to the SDK?
No. So okay. So today, when so we have a certain order and a certain strategy we follow, right? So that
Right.
was
Yeah.
the design.
It is defined in the pipeline, right? It's defined by the pipeline. Yeah.
Now, what we turns out when we're doing the testing is actually, I mean, if you look to the way the pipeline works, is you can actually continue. You can run until it's final. So in other words, the order. At the moment we have an order dependency, but if we do some changes, we even don't have the order dependency, because actually what you see is our implementation is a staged execution of things. So in other words, let's say if you change the order, right, and you run it, okay, not everything is completed. If you run it again, it will most likely be completed. You see?
Yeah.
So and if for example, and now we are adding interface 2 times and we're adding DNN 2 times into the pipeline in order to have a single run doing the whole thing. But actually, if you look to the reality of the situation is, let's say you only do 1 interface and 1 DNN, then the first time it runs, it does the first stage of the pipeline of the function. And then the second run will do the second stage. So even we don't even have to put the functions 2 times into the same pipeline, if you will. But that means that Porch will run the pipeline again and again and again until we are complete. Now, what we see is that because of our strategy that we have adopted, that creates, so there are some, let's say, issues with it based on the current strategy. And if you run the pipeline as we discussed in the beginning, there is no issue. If you want to run this staged implementation, and you would say, okay, I don't care about the order, and I just want to run it all over again, then we have to do some changes.
But do you think when we need that for R1? I think R1, I thought.
No, what I propose is that we freeze what we have, right? Because it works. And then there are 2 enhancements that I want to do, but I think we should, because we have a bit of bandwidth still. So I propose that we start working on it, but we keep it separate for now until we know that it works. But so at the moment, I would freeze whatever we have, because we know that that the pieces that we have actually works.
Yes, I think that makes sense.
And then we can, in parallel, on a separate branch or something like that, with a dedicated PR, continue on it, because it will enhance it eventually and simplify things. So that's it's good for everybody at the end of the day.
Yes, that's fine. And I think if you're feeling confident, if it comes, like, for example, if the changes come this week, we could even merge, that's fine.
Correct, yeah.
What does that mean to this particular item that Istvan was talking about? Does it have any implications on this one, or can be, or Istvan, were you suggesting something else?
I just pushed into this PR commit, and hopefully after all the tests are run, everything will be green. And I think it's fine, as Wim said, that is what we have right now. It works. As he said, the only drawback that we will have to put interface FN twice into the same pipeline. It's not a big deal. We can do that. So I just pushed a new commit into this package specialization pipeline tests PR, and it will need an LGTM and an approve, and it can be merged.
Cool. Thanks, Istvan. So probably once the tests are green, we can.
Yes, I hope it will happen in a couple of minutes.
Cool. Awesome.
The tests are running right now.
Cool. Thank you.
Yeah, so that's the situation basically. And then it's done.
And the to-do list, let's see. Edge Watcher, it's not really this it's Stephen.
Steven is
No,
not here, right? Or Tal is not here. I
Stephen,
don't know
no,
what is this. Yeah.
yeah. Then we need to definitely ask that one. The other one is implement detection of new clusters in Edge Watcher. That is again the same thing.
This one, the Bootstrap controller is done, right? To
Yeah,
install
yeah.
config sync, but not the Watcher agent. Actually, even the Bootstrap controller that I wrote installs it as long as someone puts the Watcher agent into the staging thing, it will install it. So the Bootstrap controller right now is very generic.
Okay.
So what it does, it basically, I did one change actually after testing this whole cluster installation. So I did some, I have a new PR open for it that we should approve. But so what it basically does, it's so there is a staging repo, and anything that is in there that is marked for the cluster will be installed by the Bootstrap controller.
So when
any
you say staging
package,
repo, is it like upstream repo? Is that what you want to? Is that what it is, or like a blueprint repo?
yeah. So in port you register repos, right?
Yeah.
And so when I do the Nephew installation, I went through the whole install this morning. I actually during the weekend while I was on holiday, I was working with John on the install. Right. So what you do during the install, we install initially two repos: a management repo and a staging management repo, if you will. The difference between the two is that the staging managing repo is not marked for deployment. The other one is. Okay. So any package that we want to be installed independent of config sync. So because we have a problem if we set up a cluster, we need config sync to be set up, right?
Yeah.
So that's the idea, or that's why John wanted to have that controller. So what that controller basically does, it actually install. So it was meant to install config sync. Right now, the way it is designed is that any package that is marked. So if you put package on the staging repo, right, and it's marked for that cluster, it will be installed. So in other words, if config sync Watcher agent is there, I will install it. Because I don't care whether it's config sync or anything else. I just install whatever is coming there.
Okay.
Oh, so config sync, you said cluster. On a cluster, config sync needs to be installed, right? Or are you?
But I remember which actually this is a bit of a topic that has been done in package management, right? So you know that we have discussed this consuming Nephew to install Nephew, right? That's basically the whole thing. Yeah. So
the Bootstrap controller and all that stuff. The Bootstrap cluster and all that stuff. Yeah.
Yeah. So basically, when you set up a new cluster, right? The problem is how do we get config sync installed on it, right? Because someone has to. So if you want to automate the whole installation, we needed something to do that, right? That's what the Bootstrap controller is about. So the way that Bootstrap controller works is basically it looks at the repo which has the staging flag or key set up as an annotation, and it uses that to figure out which packages belong to that cluster, and then it installs them. That's basically how it works. So this is actually.
Yeah, while we are on the topic, Wim,
yes.
If you can again help this group understand a little bit more about you also talked about something about the tokens, how you are accessing the cluster to install config sync, the target cluster. If you could add a couple of lines there, that would be useful as well.
You had a slide deck, right? Initially about 3 weeks back that you presented. I know we all had a glance at it, at that point of time, but you are in the midst of it. That's probably where I think Bala's request is too, right? So
the best is actually to demo the whole thing, but the problem is a bit deletion takes a bit of time. But maybe I should go through my script. I actually have documented what I've done. Where did I do it?
yeah, I mean, if some of these things we are asking for repeat, it's just that there's so much information.
No, it's not. It's not
Bear with us.
repeat. It's definitely not repeat.
Yeah.
But I have an action open to document it better. But I just finished. So actually this morning I finished going through the whole thing and installing the whole thing in one flow, right? And I had to do some modifications for it because also there were some change. I like config sync doesn't like to have something that is in the config sync namespace to be synced with config sync and stuff like that. So there is all kinds of tricks that I had to go through to make it work. And then we had all kinds of issues with this package variants and package variant set that we had to deal with. So, but let me, okay, so what do we have here? So this is the high level drawing, which confuses sometimes people. But what I try to do is document it in this way. And it's not yet ideal, but I will go to the next stage, which will be a sequence diagram. But that's where I'm at right now. So in essence, what we are doing is we are installing Nephew through Nephew. Okay. To do so, we have to do a few things. So the first step is the installation itself. So let me walk you through my notes and my thing that I use to install this whole thing. Okay. So the first thing what I do is I clone Nephew example packages, right? So locally somewhere on a directory. And at the moment, what I decided to do myself, and I put a note on Slack, is we were running Git-dia on the same cluster as Porch, and I decided to change it. So I'm running right now a separate cluster to basically run Git-dia, and the reason is that you have to access it through a URL, right? Or I wanted to have it accessed through a URL, and then, but you have to set up DNS and all of that stuff for it. So what I'm doing right now myself is I'm installing MetalLB. Actually, I can show it because it's running. Get cluster. So I use, yeah.
So for my understanding is that there needs to be some sort of a bootstrap cluster, right? That will probably be manually be installed, right?
Yeah. So yeah.
And
yeah,
then
there is a few.
saying now there's going to be a second cluster that the bootstrap cluster can bring up and install Git-dia on that.
Right. So what I do right now, Vish, my flow is the following. I install a Git kind, right? A cluster called Git, right? And on that cluster, I install Git-dia. So that's my first step.
Oh, that is your first step, which is manually done.
You can do it through script. So yeah. So there, but it also uses kept live apply and stuff like that. Yeah. But so this would be still through a script, yeah, to do so. Because the reason I did it, I changed my mind here is, if you use GitHub or any local environment, my assumption is that it's most likely that this Git server will not run in Porch in the same cluster as we have it. That's why I separated it.
Okay. And if somebody were to follow it like a workshop VM thing, in my mind, I'm thinking if you have a newly created VM, the first thing that one should be able to do is go create a cluster which has got Git installed. That is what you're suggesting. That's what I'm following currently at this point of time, correct?
Yeah, what I'm suggesting actually is that if we create a VM, right, it's already running. So what I would do is I would basically create a VM where if you set this up, right, the kind cluster already, that thing is running already.
Okay.
That's what I would do. then they don't have to bother about it, right? So it's either they say we own, so like nephew takes care of Git, or they use their own, right? They could still do that, right?
Yeah.
So then, okay, so that's a discussion. I put that link on Slack, so I'm not sure whether someone replied already, but that's one thing that I put
saw
on
that,
Slack.
but trying to digest it, and I was thinking that you'll probably give some information here too, which is good.
Yeah, okay, yeah. So this is the whole reason why I'm doing it, because also our packages, right, will refer to that URL somehow, right? And so the problem is that so either you have to set up a whole DNS infrastructure that is uniform between locally in the cluster and remote, right? Or you do what I did. I basically use an IP address, which I expose from this Git server, which is this IP, right? Which I install via MetalLB. And just I point the URL to this IP and all is good. But I think we should discuss that tomorrow in the package management meeting, how we do about it, how we go about this, right?
Okay. I think you have a PR on the README and some stuff associated with this, right? I'd opened it up to read.
Yeah, so I think that is, irrespective of whether we do this or not, is useful, right? Because it allows, before there was too much dependency that the Git server had to be running into local cluster, and I think this is not good in general. So what I did change in the Git client is I changed the fact that before I was able to get the Git server via the secrets, via the service in the cluster, but it makes it very specific to running it within the cluster. So what I did change is I changed that, or rather than going for the service, I say, give me a URL and I don't care where it's located. And someone needs to take into account that I can get access to it, right? That's basically what the change is about. And that's how it typically works also with GitHub or GitLab and stuff like that, right? So you basically get a URL and then you access it and you provide credentials, and that's it. You see? Okay. So I'm assuming somewhere Gitia or something is set up, right? This is just something for me. I can access it over the internet.
Yeah, it's good actually. I think a lot of people, right? They may not have anything. This is a good script for him to set it up. Thank you.
Yeah, I was going to share this, but for example, here I can access my Gitia straight from my laptop, and this VM runs in Google Cloud right now. So
yeah,
you see. So that's the nice thing about it. So you see here all the clusters and stuff like that. So I actually went through this script to make this happen.
Okay. So mainly the problem statement for using Gitia, as I understand, is that if you want to do everything locally on your own laptop or on a single VM, that is where Gitia comes in, and where you don't have access, let's say, to the internet. So that is the use case for using Gitia, because you want it running locally. But if you already have an access to, to be able to communicate externally, you'd probably prefer to use GitHub, which would be the production use case. I mean, just trying to bring it out to
No, that's correct. Yeah. Now we still have some dependencies, for example, at the moment. So we didn't do that change yet. So for example, the token control at the moment is tied to Gitia, but we should make it generic, right? So that was the goal always, but I didn't have time yet to do it, or someone else can do it.
And
so
also
to make
because some of those things like tokens, secrets, and all that stuff, it's okay for somebody to do it internally on the same machine. You don't have to be very security conscious as a first step. I mean, of course, I don't want to water down security here, but running locally, you can always use nephew on default, because you're doing it all locally on side of your VM, and it is a closed access within that. So because when it's not like the GitHub token, you don't want to share that with anybody else, because it's actually, hosted elsewhere, and you don't want to lose access to that. But if it is all within your same dev environment, or within the same VM, or two VMs in the same desktop, it should all be fine.
Yeah, that's correct.
So the other use case, which is somebody doesn't want to use GitHub, still be a production use case. Somebody may wants to use their Bitbucket, for example, which is another commercial distribution of Git.
Correct. Yeah. So, okay. So the next thing, what happens? So now we set up a management cluster. So this is basically creating the management cluster, right? What the extra mount here is actually, so this is coming from Victor scripts doing that. So we mount the CNIs in, so it's a bit easier to set up the clusters by doing so. So we mount the CNIs in the VM at the moment, because it allows us to, you don't have to separately install them and stuff like that. So they are part of the VM, and then the kind images mounted from the local VM. So as such, the kind cluster creation uses these CNI mounts that the script I basically downloaded. It's basically just copying the CNIs locally on a VM, and just when you install the Docker, when you run the Docker images, you basically mount, you basically share that volume with the Docker image, and yeah, that's how they get access to the CNI. So it eases the installation. Okay. So then, so here what you see, okay, whether I do it or someone else doing, you see it, if I don't use Nephew example packages here, it means that the package is not yet in our mainstream repo. So config sync needs to be uploaded. Someone needs to upload config sync into our example packages. So, okay, so then I install a number of packages via cat live apply from the example packages that we have. So I install config sync on the management cluster. This is Porch. I install a secret to get access to Gitea at the moment, and this could be right. And then I install. So this is my version of the Nephew controllers. So I have my own flavor of the Nephew controller. So this runs Bootstrapper, Bootstrap token. This runs Bootstrap token, the specializers and stuff like that. So I actually made already a version of this.
Sir,
I think, yeah.
Sorry to interrupt, Tim. Is there any place where we can see the Nephew config sync or the Nephew package, even if they're not, finished? Because it really would help with the understanding of this, as we could step through this,
So I have, you will see in a bit, I have a repo, which is, wait, sorry, where is this? I have a repo, which is public, that actually has the manifests that I'm using, which is this actually. So here you will see that, so this is Nephew cluster kind, so that is ours, right? So that's the one that that we have checked in. So this is config sync here, right?
Okay.
You have Nephew repo, so you'll see in a bit that I'm going to use Nephew repo. I have root sync, workload cluster. This is the original, so this is where we had some bugs, so it's still there. But these are the packages that I'm using in a bit, right? So, and this is public, so you can access this out of the box. I'll give you the link, git remote -p. So this URL should give you access to this.
But thanks, that's really good, really helpful.
Where should I put it? On specialization or on management?
Whichever. I'm following both, so doesn't matter.
Yeah, I think it's better that I put it here, right?
Yeah.
All right. So this is
Thanks a million, Vince. That's really helpful.
yeah. So this is the packages that I have, right? So okay. So I set up config sync on the management cluster. I create Porch. I create a secret to get access to Git. I install the Nephew controller. So this is, I install the resource backend. So this is the IPAM, right? And then I have the additional packages. So like cert manager. Now this we could also install via the, Also this one, by the way, we could install. So all of these are mandatory as kept live apply. So we could also, I think Victor has a script for this, right? That does that. But that's all you need. So all the rest, if we make all of these available via NFO example packages like this here, you could basically use the UI to install this if you want, right? So at the moment, I'm doing it still manually, but you could use the UI to install. Okay. And then also, this is actually the repo that I just shared. So this is basically what you could say.
So
Yeah.
Wim, before we go there, would you mind giving a 10-second on each, what each packages are?
Yes.
Yeah.
So this is Cert Manager. So
Yeah.
they're all dependent on each other, but this is Cert Manager. So this is the cert, so that's doing certificate handling in a cluster. It's used by several things, but yeah, so copy, so cluster API is using it. So that's why you need Cert Manager, right? So far, we have no use case for it other than cluster API, but it's used quite a bit in Kubernetes, I think. The second is cluster API core, right? So this is the cluster API core operator. So this is copy, so that's actually installing this and that. So this is basically automating kubeadm installing, right? So everything that you see with copy here is installed through when you do this thing, okay? The next thing that we do is so the way cluster API works is that you have providers, right? So for us, we use Docker provider. So Docker provider allows you to install kind or any Docker, any cluster using Docker. I don't know whether there's a Podman version, Vish, I don't know. But so
I was trying to look for it. I have an action item to look for it though. Yeah.
Yeah. I didn't do the
That's fine
myself, but
because we're getting started. Just like how in the last time we used Docker and later added Podman support, we can always do that.
Yeah. So yeah, so this is basically installing the Docker provider, if you will, right? So we created already Nephew packages for each of them, right? And then the next thing is actually a set of templates that we use for our environment. So, and one of these templates, so I was referring to in the beginning that we mount the CNI, right? So one of these templates uses that CNI that was mounted here directly. So it's not really the CNI installation, it's the CNI binaries like SRIOV, IPVLAN, MAC-VLAN, and so on and so forth, right? And so if you look to this template, it's actually leveraging that CNI mount that we did in the beginning. Okay. So now we have all the packages. The other thing that we have not yet done is there are a set of additional packages that we were working on that allow us to do that installation, right? And that is where my story begins, basically, where this slide basically begins. So what you see is that to install a cluster, we created a Nephew workload cluster package. And that Nephew workload cluster package has a set of PVs. And each of those PVs mount to another set of packages. Okay. If you look to my blueprint thing that I shared, what you see in there is the Nephew workload cluster that you saw in this chart here. Right? So you see here, this package here is actually this package here. Okay. Then you see here the package Nephew root sync. So I will change the name. You see that this is root sync. So that's that package, right?
So, Wim, is that Nephew workload cluster same as where you are running your Gitia? I mean, as an external service?
No, so this will use Gitia. You will see in a bit when I explain it, hopefully. You will see how it leverages Gitia, because this manifest is getting applied to the cluster, and then the repo controller is going to create let's say a repository in Gitea or whatever Git URL. At the moment it's tied to Gitea. If we make it GitHub or any other provider, we can make it generic, but at the moment it's tied to Gitea, the repo controller. So what happens is, as part, so what you see here is that in this, so let me first explain all of them. So this is the config sync software. So this is, I call it Nefio config sync in the meantime. Okay. Then Nefio root sync. This is Nefio repo, I think. Yeah. Okay. And this is Nefio cluster copy guide. Okay. So you see them all being referenced here, right? So if you look now into, so what is the workload cluster repo contains? It contains a set of PVs. Okay. And these PVs, they upstream tie to Nefio cluster copy kind, right? So it ties to this package. So what you see is you will have a recursive installation of these packages. So what we will do is we will apply a PVS that refers to this workload cluster that will create a set of package variants, and that those package variants each refer to those packages, and they all get mutated with the necessary names through that whole installation process. Okay. So you see how
to understand where is the bootstrap controller running. So we have one bootstrap. I mean, what I understand is that you have one cluster where these which has some pods installed already. That basically that's where your PV cluster repo. Some of those PVs are kind of managed. Is it
yeah,
right?
so
I mean, I'm just trying to understand where the bootstrap controller is here. So.
The bootstrap controller runs on the management cluster. So if you look at my management cluster here, right? So the bootstrap controller, you see, actually it's running in Nefio, okay? So in Nefio system, so this Nefio system controller contains a set of controllers. What are those? Bootstrap, there is actually two flavors. The Bootstrap has a token and has a package. So you have Bootstrap token and Bootstrap package. You have a token controller and you have a repository controller. So there is 4 controllers that are used in this cycle. And what do those controllers do? So the token, so the repo controller creates repos. Okay. And at the moment it has a backend with Gitea. So but the idea is to make it more generic. But at the moment it's Gitea specific. So if you see during that process, we will create a repo CR in the management cluster. The repo controller picks it up and creates a repository in Gitea. And the repositories that will be created, you see here, I created these. So there is the management, there is the staging, and then there is the one representing the cluster, right? So, but these two have not yet been created. So I will explain you in a bit how they, so they also get established or created through the same packages that you see in the beginning. So you could use this package. So what I try to do is build a package that you can manually install, or you can do you can use during automatic install, and it's the same package. Okay.
Mm-hmm. Are you introducing some new CRDs here for cluster provisioning and all that, or?
For cluster provisioning, we did not create a new CRD. The only new CRDs that we created are the token and the repository one. That's the only 2 CRDs that we created. So there is a token one and a repository one.
Okay. Yeah, I mean, it would be good to show some timeline diagram.
Yeah,
This-
that's my next step, but I focused on getting it to work. So now it's about
Okay.
getting education going. So one step at a time.
Thank-
Yeah.
thank
So
you.
we have now the base thing works, right? So now we have to start educating and sharing this, but there's a lot of stuff going on under the hood.
Sure, yeah,
See-
yeah. It's difficult for me to connect the dots right now. So
Yeah, it's recursive, so it's sometimes even hard to figure out what happens under the sun. But okay, so basically we have these packages. Yeah, so these packages. So what you will see is that if you look to this repo package, so why did I change? I split rootsync from the repo, for example. I split them in two. The reason is mainly because I wanted to use both of them to do manual install, right? And of course, rootsync is something that is needed on the workload cluster and not on the management cluster. But I wanted to use a flavor on the management cluster as well as to use it on the workload cluster, right? So that's a bit what makes it also interesting, because that means also that we no longer need a dedicated thing here. But what you see is with package variants, they have an upstream and a downstream, right? And it can only be one. So now, because rootsync needs to go, so all of the repo stuff needs to go to the management cluster, whereas the rootsync, in certain examples, it goes to the management cluster, and in the other example, it goes to the workload. So you cannot combine it into the same package. That's why it's split. Because in some cases, the destination is different than this one. Okay? So that's why the root sync is split, and it's also split from config sync, because I'm of the opinion that root sync is actually the thing that you need, that is there to configure config sync, and it should be separated from the main software, right? So I also split it because of that. So yeah, so that's kind of a little bit it. So you have now a bunch of
So
packages
is the
here.
root sync today part of the config management system?
Root sync is a CR. So if you look to config sync, in theory, you could have multiple root sync on the same config sync.
Okay.
And so you could have multiple, you could have multiple ones in the same cluster. And I believe there is an issue that John wants to address that wants that. And so I'm going to look into that next to see how we can make it more flexible than what we have today.
Okay. So the config management system is a namespace in which this root sync will get installed. Is that right?
That's correct. Yeah.
Okay. And that's where, like, for each of the, if you have, I mean, you'll probably have a pod being created for each of the repos, right? If you
There
have
is-
four, let's say if you have management, edge 1, edge 2, and region 1, then you'll actually have 4 of those pods for each to map to each of them, something like that.
No, there is no.
Maybe my
what I
question is
mean,
totally dumb too. Could be.
there is a different way. So you don't have a new pod for it. You just have a set of CRs representing that workload cluster, right? And you have you have a set of CR that represents the workload cluster. What I decided to do differently than we did in the Ansible playbooks is I created a token per client. So if you look to my Gitea server, right? You know, in the workload cluster, we basically have one token and then we were fine, right? But I didn't think it's very good security-wise. So in other words, if you go to security,
Well, from a
here,
Gitea perspective, that is why I was like earlier saying about the conversation, since Gitea is going to be used only locally on the same VM, that is why I was thinking it is okay to have that because we are trying to do it on the same VM or like not two co-located VMs.
yeah, but I created them I create dedicated access tokens for each cluster, and a different one for ports and a different one for config sync. So that means that if one is compromised, you can just revoke one and the rest continues to work. Right. But But it's a minor thing right now. So that's what I did at the moment in the scenario. But okay, so okay, where was I? So okay, so we have this thing. So this is registered. Now I'm going to use these packages to install a management, because so far we don't yet have a management cluster, a management repo, sorry, right? So we just have Porch that ties to Blueprint packages somewhere in GitHub at the moment, right? So that's still the GitHub registry. If we want to run everything local, we need to have an import script that each of these packages import in Gitea. I didn't do that. So if we really want to do a full offline install, we could actually create a Gitea repo that is where we upload all of these example packages locally, and then we can do everything local. Okay. Now, the next thing that I do is I create, you see here, so I use that same package so Nephew repo, right? I'm using it to actually create my management repo. And at the moment, these are the steps that we have to do. I asked John for an enhancement that we could add this into get package get, that we don't have to do this local config map. But so you have to basically, this local config map, what it actually does, it gives you the management repo parameters that are needed to reuse that same repo, right? So, and if you then render this, it will pick up these parameters instead of the ones that are in the package context. So that's what basically this thing does. And package variants do this for us automatically, but when you manually install, you don't have that. So this is something I would like to enhance in the pack. When you do this, I can do package context and then add these parameters, then it automatically does that. That would simplify a number of things. And I do the same for root sync. So the root sync, so pointing config sync on the management cluster towards that management repo, I also do via using the same root sync package. And also I do this local override to be able to point to that local repo. Okay. And then I have another one to create that staging repo. And here I don't need root sync because it's deployment faults, right? So what you have right now is you will have everything in white, right? So all the white components that you see here after this step are basically what, you don't have, actually you have this because it's part of the example packages. So everything in white exists right now. Okay, everything with a color doesn't exist. So then the next step is okay, no, I did that already. I have to remove that. So the next step is actually creating package variant sets. So now we are going to install workload clusters and bringing them up automatically. And what you have to do for that is basically this, right? And this is the PVS. So what you basically say is, and if you put here cluster 2, 3, 4, and 5, and so on, you will create 10 clusters or something, or 5 clusters. So if you would do here cluster 2, cluster 3, and so on, you will create 3 clusters with name cluster 0, cluster 2, cluster 3. Okay. How does this work? This upstream points to that workload cluster package that you saw in this repo. Oh, wait, I need to charge my. So what will happen is this will point to this Nephew workload cluster upstream, right? Wait, did I remove it? Yeah, I'm pointing. Wait, so let me make this a bit better here. So this points to this repo. And in that repo, you have a, right, so this is the recursive thing, right? That I was saying is that in this repo, you have a PV, a cluster PV that points to the Kepi kind repo, right? And it creates a downstream cluster example. Everywhere where you see example, it will be mutated to the cluster name that we were setting up. So cluster 01, so there will be one for cluster 01, one for cluster 02, one for cluster 03. So by the way, this is the same flow as if you were to install a network function, right? So there is no difference here. It uses exactly the same primitives.
So what does the KPT file look for this? Because I'm seeing if there's any transformations happening. Is there any transformation happening?
In here you have apply replacements, right? So here, so this is where
Okay.
the mutations are happening, right? So what we
Oh,
do,
I see.
so this is where the mutation come from, and what we basically do is we override. So what is happening under the hood is that this name example is going to be replaced with cluster 01, cluster 02, cluster 03, right? And we are using that during the mutation space, right?
Okay. So instead of actually having this in KPT file, but the KPT file should actually still point to this apply replacements, right, in the pipeline?
Yeah, it does. Yeah, it will. Yeah. So the kept file here has apply replacement YAML,
Oh,
which
okay.
is this
That is what
YAML.
it
Yeah.
is.
Yeah.
Okay. That means if I need to change the pod network, at this point of time, everything will receive the same pod network. That CIDR will be the same across all the clusters.
At the moment,
Of course,
yes, because
of course,
they are
the
local.
API server IP will be different.
Yes, correct. Yeah.
Okay.
Yeah, because we are not using external. So if you do a load, if you would install an ingress on it, then it will expose itself. Or if you use Multus with our IPAM system, you will have dedicated IPs, right?
Okay.
But for now, there's no need to change them at the moment, right? Because they are all locally within the cluster.
Just saying aloud for myself and also for others, this is all at this point of time only kind clusters running on the same host.
Yes.
For now, correct.
Yeah, but for example, if you would change this package with, let's say, OpenShift or something like that, and you would have here another YAML file. So here you see, this is the YAML file that we are using to install, right? So if you would have here a file and you say, okay, I want to mutate these CIDR blocks, right? You could also do that if you want, right? So we could also do an apply replacement for these if we want. At the moment, we are not doing that yet, right? But we could change the version of the Kubernetes cluster, how many workloads you need, and so on and so forth, right? So that's all changeable if you want.
So
Right.
just one question, Wim. So the starting point for this, the whole cluster provision, is this the manifest, or is it you start with the PVS? Is this generating the PVS, or is this the starting point?
PVS, the starting point is the PVS. So once you do the PVS, all the rest will happen. Of course, you have to still go through approval, right? Which is, it's a bit too much in my view, but so we have to discuss that tomorrow. But so this will install the whole thing. So the only thing that you need is the PVS. So this PVS here, that's all, and the whole thing goes.
So when you say approval, you're talking about those publishing and approving it, and before it gets picked up. Is that what you're trying to?
Yes. So because what happens here? So this one creates a new draft, right? It's basically this one creates a new draft of all these workload cluster PV, right? So you will see that. So if you have 3 clusters, you will get 3 drafts, basically, right? If you look to my setup here, at the moment, if you do kept remote pack alpha, sorry, remote package kept. So you see here, so these are the original packages that came from my blueprint manifest, right? So the 5 that I shared you before, right? This. What was the iPad? Too many things.
Okay, so it skipped all the draft and everything. It just got published. So I mean, I'm
No.
not communicating
It's, you have to go through that. You have to. So that's the bad. I think the thing that I would like to improve is to see whether we can do something there. right? Because what happens, first step is this gets done, then I approve, right? It now creates these 4 mains, so which are representation of each of the PVs that I was showing you, right? And then I have to approve each of these individually, and then they will instantiate it, right? So you have to go through a bit of approval to get this going. You also
that's the whole
see,
point, actually, right? The designer.
now
and
it's good and bad. Yeah. In the meantime, I created a script for myself that does it automatically.
Okay, so it goes, looks at all the drafts, it goes and approves it and publishes it. I see.
Yeah, you could make some scripts we could automate something. So there is some room for improvement here, I think, right? But yeah, so we just approve. Let's say everything is fine. You just approve, and the whole thing. All of a sudden, you have kubectl get cluster, right? Dot clusters dot tips and So this is cluster API. You have a cluster up and running. If you look to that cluster, kubectl minus kube config slice.kube cluster 01, right? Get pods. You see config sync got created, right? You see kubectl get, same thing. So, get root sync minus a. Okay. Okay. Something. Maybe I have to look what happened here. Okay.
Maybe we did get pods minus a. Should it? Oh, you're looking for the CRD?
Yeah. See the secret got installed.
Get all minus a.
Get all?
Yeah.
Okay. You want to see it? No, the root sync is somehow disappeared. Okay, I'll have to look at.
That's on the which cluster is this?
No, this is on the cluster 01.
01. Then, okay.
Okay, I'll have to see what happened here. This was running before, right? You see in Gitea, you have all the clusters up and running. You get, so here you see the management cluster. You see cluster 01. You see all the stuff that are happening. So this is the actual CR that got instantiated. You see here that cluster 01 got changed. The example got changed. If you look to the management, the cluster repo resources, here you see the Gitea repo, right? This is the Porch one, right? This is the tokens. Not much to do here. So all of that, somehow got inserted. Yeah, I have to look into the root sync thing. But yeah, so basically this is what's happening. And what I try to represent in this chart is the flow on how that gets applied. So first is all the CRs related to Nephew workload clusters, so which are the PVs, right? So what I said is, so this is the package, gets installed here. Once this is approved, config sync will pick it up on the management cluster, install these 4 root PVs, these PVs onto the management cluster, right? That by itself triggers the PVs in Porch to act, and it will install these 4 packages, 2 on the staging repo and 2 on the management repo, right? So the cluster one is here, the repo here, root sync here, config sync here. If one approves these, what you will see is that in the management cluster, you get a cluster CR, you get a repo CR, and you get token CRs. The cluster will be picked up by cluster API. The repo will be picked up by the repo controller that we did. The token will be picked up by the token controller. So the token creates tokens in Gitea. The repo creates repos in Gitea. The cluster creates cluster API. And then what you also have is that the Bootstrap controller, I didn't show that yet into the picture, is looking at this repo, sees okay, which packages are here. They see they are belonging to cluster 01, and he's going to install them on cluster 01. And there are two, I said the Bootstrap has two flavors. One is the secret, and the other one is the packages. So there is Bootstrap packages and Bootstrap secret. So the secret is picking up the secret that is tied for config sync and putting it here such that root sync works. And then root sync and config sync are picked up from the staging management repo, and we know that they belong to cluster 1 based on annotation, and he will install them. If you would put here other packages, it will also install them. As long as they are tagged into a staging repo and they are destined for cluster 01, they will also be installed. And what also happens is that this workload repo, so for the cluster 01, is also automatically created using the repo controller with the necessary tokens to have both Porch access this repo as well as config sync accessing this repo from the workload cluster.
So there's only one workload repo, right? Basically.
No, but so this is cluster 01, right? But if I would put here 10 clusters, it will create 10 clusters.
Yeah, 10 clusters. Yeah, but will there be like a repo created for each?
Yes. Yeah. Yes.
Workload cluster. Okay.
Yeah.
So I was thinking about this other day, like, if somebody were to create 1,000 clusters, which means you actually end up creating in an organization, if you have a GitHub repo, you will end up actually creating like 1,000 repos in the organization, right?
Yes.
That's how that seems to be one of the, I don't know, I'm not used to customize yet. I don't know how that works, but I was thinking like, for every, that means there's a one-to-one correlation between a repo and a cluster.
That's
now it doesn't have to be.
Yeah, that's the current design, but I think there is a way to change that if you want. But of course, we have to look at it end to end. But yeah, at the moment, there's a one-to-one relationship.
Sorry, I think I've been asking too many questions. We are over time.
No, it's okay. Yeah, okay. Yeah, we are over time.
So Wim, one last question. I know we're over time. I'll just take 30 seconds of your time, and then probably can end this. So I know the CAPI creates the cluster, and then this Bootstrap creates the config sync, installs the config sync on that directly.
Yes.
By contacting the cluster. So I just had to miss this call for 10 minutes in between. So you might have covered during that. So how does Bootstrap get access to the cluster credentials to?
So there is a secret which is being created by Cluster API on the management cluster, and it picks that up.
Oh, okay. It stores on the management cluster. Okay, got it. Okay. Okay, thank you.
Yeah, so the Bootstrap cluster, the way it works, so there is two flavors, but packages, and there is one for secret and one for packages. So the secret is there to install config sync into it. So the strategy I have for secret is that, so a token creates a secret in the management cluster based on in the namespace it has, and there is an annotation that basically identifies it that it's for config sync, right? So the secret manager watches secrets, and it sees that, right? From the moment it has that secret, it tries to see what is the associated secret to get access to that workload cluster. So it's, and the way it does it right now is that, and we have to see based on each cluster deployment, let's say controller, how they work. We could use other strategy, but that code is already fairly generic, right? So what I try to do is build an interface, and what that interface does, it's basically I give it a secret, and I try to figure out what type of cluster provisioner it is, and also get the information from there. And then so that's what this one does, and the package one does the same thing. It uses the same code, but here the difference is that he acts on packages, whereas the secret bootstrapper acts on secrets. And but under the hood, from the moment they see there is a package I need to install, they use the same code to get access to the credentials of that cluster itself.
Okay, got it. Thanks.
Wim, one quick question. That one on the leftmost kind of the block, you have PV cluster. That's actually not a cluster. That's simply more an information. The PV is related to the cluster. That's what you mean, right?
That's a package. That's a package.
Oh,
This
okay.
is,
Yeah. But I was getting confused that, okay, that's a cluster instance. Okay, package. Okay, got it. That's what was confusing. Okay.
Those are all packages for the workload cluster is my.
Yeah, these are all packages as well, right? These are all packages because there is way more information in there, but I try to summarize them. Here I try to, in this picture, I try to, so you see, this is exactly the same as this one, right? But this one is basically having this upstream reference towards other packages, see? So, and what I try to represent here is actually, so cluster, I'll have to change the naming right now. Cluster is the same as this one, so there is only one CR in here. But for example, repo that I represent here as a single blob actually has 4 CRs in it.
Okay.
The question is, how do you make this all visible in, but I think the sequence diagram is the way to do it. But yeah,
That would be great. That will help us a lot. Thank you so much.
Thanks. Yeah.
But yeah, so this allows to install clusters right now. But what you see is that the flow that we use for network functions is the same. Right, so it all starts from a PVS that refers to, so we'll have UPFs. So this will be UPF, SMF, AMFs, and there can be a few of these, right? But the flow is the same. There is no difference, except that the packages are different, but the way we consume this is going to be the same. Right?
Yeah, absolutely. Yeah.
Good.
All right.
Thanks, Wim. Yeah, appreciate it.
Anything else for now?
I think from the code freeze perspective, I think we are looking good from this group. I think probably we'll go to the release meeting later and figure out how we look there.
Yeah, indeed. Yeah. All right.
Thank you.
Thank you.
Cheers.
Have a good one.
Yeah.
Thanks, Wim.